Hey guys, welcome to my channel and I'm back again with another really interesting coding interview question video. In this video guys, we are going to solve question number 338, counting bits. So without taking any time further, let's get started. So first of all guys, let's see in which companies this question has been asked. So you can see the companies are Google, Meta, Bloomberg, which have been in the very recent past, and then it has also been asked in companies like Amazon, Microsoft, Uber, Nvidia, and Adobe. So pretty much are very popular questions among the top tech companies. Now let's study the problem statement. Basically guys, we are given an integer n and we want to return an array answer of length n plus 1, and we want to put such values in that for each I which goes from 0 to n including n, the answer I is the number of ones in the binary representation of I. Let's see this example. So suppose we have got n equals to 2 and the output is equals to 0, 1, 1. And how is it? Because we will start from I equals to 0 until I is equals to 2. So if we have got the value 0, the number of zeros in the binary representation of 0, the number of ones in the binary representation of 0 is 0. Okay, so we have got 0 value here. Now the number of ones in the binary representation of 1, which is also 1, is actually this value. Okay. Now if we talk about the binary representation of 2, it is represented as this 1 and 0. So that's why the number of ones which is present in this binary representation is 1. So we have got the output as 0, 1 and 1. Okay, and if you see another example here where n equals to 5, you can see 0 is represented by 0, 1 is represented by 1. So we have got 0 and 1. Then 2 is represented by 1, 0, and the number of ones is 1. So we have got 0, 1, 1. 3 is represented by 2 ones. So the number of ones is 2 and answer is 2. 4 is represented by 1, 0, 0. The number of ones is 1. So we have got 1 here. 5 is represented by 1, 0, 1, which is again represented by 2 here. Okay, because there are 2 ones. The constraints are that the n can go from 0 to 10 to the power 5. And what's the follow-up for this is that we can come up with a solution with a runtime of n log n. But can we do it in a linear time complexity and in a single pass? And can you do it using any built-in function like built-in pop count in C++? So obviously guys, we are not doing any built-in function. So this particular point here where we should do it without any built-in function is definitely gonna check for all our solutions. But this other follow-up point, we will first see a normal brute force type of solution and then we'll try to optimize it. Okay. So now that we have understood the problem statement, it is time for us to start solving it. But first of all guys, to start solving this problem, we need to understand the solution approach, and for that we need to understand how you can actually calculate binary representation of a number in like simple maths. Okay. So I am just gonna copy paste this comment right here, and this pretty much explains how you actually generate the binary representation of every decimal number. So basically guys, you can see that let's say our number is 4. Now to represent 4 in binary, we simply start dividing it by 2 and we keep dividing it until we have got 0 left, okay, in our answer. So let's say 2 and 4. Okay, so 2 divided by 4 is actually 2 into 2 is equals to 4. Okay, so if I divide 2 by 4, my quotient will be 2 and my remainder will be 0. Okay, so this is the representation. You will place your quotient in the middle and you will place your remainder in the right hand side. Okay, and you will continue doing it until unless your quotient actually becomes 0. Okay, now to divide 2, you will take 2 into 1, right? So 1 becomes the quotient, and again because 2 is an even number, the remainder is going to be 0. Now to divide 1, because 2 is greater than 1, you have to write 2, 0, right? So it will actually be represented by 2. It will actually be represented by 2, and the quotient this time will be 0, and the remainder value will be 1, right? Because 2, 0 2 into 0 is equals to 0 and the remaining value is 1. Now here you can clearly see guys that the quotient we have now received is 0. After this you cannot divide 0, right? You cannot go any further. So that becomes my final statement, and hence the answer of what is the binary representation of 4 becomes 100. Okay, and that is my answer here, right? This is how you actually solve this question in simple maths. Now I am just going to create this entire thing in code, okay, and I will explain you again line by line how I am actually doing it, and you will actually relate that this is exactly what I just taught you in simple maths. Okay, so first of all, to solve this problem in code, I have created my result object, which is a list, because again you have to return a list here. Then for I in range n plus 1, because you have to include n, the range must go until n plus 1. Now we have to create a variable called as sum equals to 0, right? Because what we are doing here is we are actually summing the number of ones. Okay, so for example here 1 and 0, 1 plus 0 is 0, right? We are summing the number of ones, we are counting the number of ones. So I have created this variable. So now we will check for every single I. First of all, if the I is not equals to 0, we will start calculating this counting bits. If the I is equals to 0, then we know that the number of ones for 0 is actually going to be 0. So we simply append the 0 value into my result set, which becomes like this. Okay. If the I is not equals to 0, I created a temporary variable called as num, and I have made it equals to I. Now, while num is greater than 0, where num is actually represented by this middle quotient, okay, while num is greater than 0, we are going to first of all find the remainder of none by dividing it by 2. So num mod 2, which is the remainder of num after I divide it by 2, and this remainder will give me the number of ones that are left. Okay, if the remainder is 0, that means there is no one. If the remainder is 1, that means I can count that one, and I will just add that value into my sum, and this will give me the count of ones. If this value is 0, nothing will be added. If this value is 1, the sum will actually increment by 1. Then what I do is I simply divide by number by 2. And what I do here is that I take a divide where I sort of truncate my number. I don't actually make a decimal divide. I make like an integer divide. So for example, if you are dividing 1 by 2, in this situation, it will actually lead to 0. Okay. Now, once you have your number divided by 2, you are actually in the second level of this quotient. Okay. Now your value is 2. And again you will go through that loop again, and you will come into the third level, and again you will come into the final fourth level where your number has actually equals to 0. So this while statement will no longer hold, and finally you would have gotten the number of ones for the binary representation in that number into this sum1 variable, and then you can use this sum1 variable and append it to your result set. Finally you can return the result set. Okay, let's run this code guys. Let's see if this works. So you can see it gets accepted, and it will pretty much work for our submissions as well, but you can see it's pretty bad in the ranking as for now. And if we talk about the time complexity here, it is the same time complexity which we were not supposed to make, which is order of log n log n, because n is for obviously this for loop here, and log n is because we kept dividing by our number by 2. So eventually it will be the log n times we will be going through this while loop. Okay, now how to actually resolve this problem? How do we create a solution which doesn't go multiple times and actually keeps us doing that, right? And the answer to that is dynamic programming. So what you can do guys, let's say if you have got this solution where you want to find out the number of ones for 4, does the number of ones which are present in 4 actually depend on any of the numbers that we have already calculated? Does it actually depend on 2? Does it actually depend on 1? Does it actually depend on 0? Does it actually depend on any of the results that we have already calculated? And for that, guys, I will actually show you a different image and a different diagram. So let me just copy paste this to you here. Okay, let's try to understand this first. So let's say we have got our number 4 and your answer is 100, right? Now if I take the same number and if I don't take the same number, but I just simply do number 8, and you can see the value of the number 8 is 1000. Okay, and what this basically tells you guys is that if your number is a even number, and let's say if 8 is a even number, the number of ones in this even number is actually equals to the number of ones which you have found in a number that is divided by 2. So if I take 8, all I just need to do is find out what are the number of ones in the number that I calculated, which is 8 divided by 2, and that is equals to 4. So if the number of ones in 4 is equals to 1, that will be the answer for 8 as well. Okay, so all you have to just do is half that number and find out the result for that half, and that will be the answer. And because you can clearly see it, guys, all we first do is divide the 8 by 2 and you get 4, right? And after that 4, it's actually the same. The number of ones in 4 is the exact number that you will find. Similarly for 6, if this would have been 6, it would have been the same. The number of ones in 3 would be the number of ones for 6. Okay, all you have to do is divide by 2. So that is one relation. Now let's look at the odd numbers, because even numbers is straightforward, right? You just divide the number by 2, find out the answer for that number, and that will be the answer for your bigger number. What happens in odd number cases? So in odd number cases, guys, you can see that let's say we have got 3, right? So 2 into 1 is 2, your remainder is 1, and then 2 into 0 is 0, and then your remainder is 1. So 1 is basically your answer. So this is for 3, right? Pretty straightforward. If you go for something like 9, which is also an odd number, right? So if you go for something like 9, which is also an odd number, what happens is that you take 9, you divide 9 by 2 and it becomes 4. And then you can see for 4 my remainder is 1. But after that I have got this 1 as a remainder and 4 as my quotient. If I look into the rest of the calculation, it is exactly the calculation for 4. So 1 0 0, this is the exact calculation for 4. All I just did was I added a 1 to it. So in case of odd numbers, you have to just take the number divided by 2 and find out the calculation for that number and just add 1 to it. So same situation is in number 3 also, right? So if I would have gotten the number of ones in the 3 divided by 2. So if I divide 3 by 2, what will be my answer, right? So the answer would be 1. So number of ones in 1 is 1. All I just need to do is add 1 to it, and 2 will be my answer for the number of ones in the binary representation of 3. And that is exactly what I am getting. Same in case of 9. So 9 divided by 2 is equals to 4, right? And if you just do the number of ones in 4, which is 1 0 0, so is actually only one number in 4, just add 1 to it and the answer is 2. So for 9, if you just count the number of ones, it's actually 2. So this is the only trick that works pretty well, that for even number you just divide the number and you calculate the answer for that number. And for odd number, you just divide the number by 2 and you just calculate the answer for that number and add 1 to it, and that will do the trick. And what you can do is, or you can just store the values of the previously calculated numbers. Like for example, in this case 4, I can just store it in my memory, and when the bigger number comes, I can just refer that number, and I don't have to do the entire calculation again. Okay, so this is called as memoization or dynamic programming. So let me just copy paste the code again so you can understand it. So first of all, what I did was I created an array which is a n plus 1 into 0, so that all my array is having first of all 0 values into it. Then again, if the n is equals to 0, we simply return this continuous array, right? Because we know that if n is equals to 0, if this n is equals to 0, there's nothing we can do, right? We can just return the one value as 0. Then we start our calculation. So for the value 0, because we start from 0, right? 0 to n. For the value 0, the number of ones is equals to 0. For the value 1, the number of ones is equals to 1. So these two things are set. Now we go from our range, that means I in range from 2 to n plus 1, where n is included, right? That's why you make it n plus 1. For every even number, if the number is even, what we do is that we just find out the value of I divided by 2. So let's say if in this case, because we have already calculated for 0 and 1, if the value was 2, that means the next value, which is this value, 2 divided by 2 is equals to 0, right? So the value of 0 is equals to 0, right? So the number of ones for 2, if the number is even, we just have to find out the division of that. So 2 divided by 2 is actually equals to 1. 2 divided by 2 is actually equals to 1, and for 1 the value is 1. So for 2 it will become 1. And let's say for 3, which is an odd number, 3 divided by 2 is equals to again 1, and 1 plus 1 is equals to 2. So the value for 3 is equals to 2. Okay, and by that purpose you will continue making it. Okay, so like here you can see for 0 it's 0, for 1 is 1, for 2 it's gonna be 1, because you will take this 2 divided by 1 value and you just assign it to there. And then for 3 it will be double ones. Why? Because you will just take the 3 divided by 2 value, which is 1 here, and you will just add 1 to it. So for 3 it will be 2, and you will continue the process, right? And here you can clearly see that you are actually not calculating all the things again, right? You're not actually calculating all the things again. You are just simply trying to use the previously calculated values, and you're trying to use them. Okay, now I just have an indentation error. Let me just fix that. Let's try that out. Okay, I think I made an indentation error somewhere. So let me try to fix that first. Okay, that looks okay to me. Not sure if this is gonna work. Okay, and this works. So you can see now I can submit my code, and you can see that this is pretty high in ranking, and this works really well. If we talk about the time complexity here, this is definitely order of n time complexity, because you can see that we didn't calculate anything again and again. We are just using the old values. So the only thing that we are using here is a for loop, which is order of n. Then if we talk about the space complexity, obviously it is going to be order of n, but I am actually the space complexity is going to be same in both the solutions, because you have to return an answer which is a list of n elements. But yeah, So that was the video, guys. I hope you guys like this video and I hope you learned something from it. If it did help you in your coding practice, then please do not forget to like this video and share this video with your friends. If you have any questions, comments, suggestions, feedback for me, please do write down in the comment section below. I would be really happy to address them. And in the end, guys, if you have not yet subscribed to my channel, please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. I'll see you guys in the next video, guys. Until then, take care and bye bye.